So in this video, we'll look at more differentiation rules, and specifically, we'll only look at three new rules. The first one is about the function cosine x. And when you differentiate cosine x, the formula is that the f prime of x is minus sine x. And the second one is that when f is sine x, the derivative is gonna be cosine x. The last one is about the exponential function. If you have not seen this function, it doesn't matter that much. You can think of e as a constant. The constant is something like 2.71 something. You can check it out by using your calculator. And the reason why we use the notation e to represent such a strange constant is that this number just appears everywhere in mathematics. This number in application and theoretically is just so important, and we decided to use a standard notation e to represent this constant. So now you have a function which looks like constant to the power x, and it's such a special case that the derivative of this case is just the same as the function itself. It never changed, and it is the only single function available in the world that you take derivative, it never changed. It's the only special one. For all other kind of functions, basically whenever you take the derivative, it's always changed. The f prime is always not the same as f for all the other functions except e of x. So let's look at some examples now. So please look at this function together. It is 3 times cosine x plus 2. So what is the derivative of this function? And as you know, when 2 is a constant, as a constant function, after taking derivative, it's going to be 0. And for the first term, the derivative of cosine x, as I said in the last page, is minus sine x. So basically, the derivative and the answer is minus 3 times sine x. Next, please look at the current function. We would like to find the derivative. And please recall what I said in the last page. For the special function, exponential function e of x, the derivative never changed. So the derivative of e of x is going to be the same. And the 7 as a constant is attached to the function. So we just keep it there. For the second term, minus 3 is kept the same. And cosine x becomes minus sine x for derivative. The third term is going to be plus 4 times cosine x, because cosine x is the derivative of sine x. The last term is going to be 4x cubed. And I'm using a power rule here. Every time you look at x to the power n, the derivative is you have to pull out the power n. Like the current case, the n is 4. You pull it out as a multiplication factor. And the power of x should be decreased by 1. And 4 is decreased by 1. So you get 3 as a power of the last term. So it's the derivative of this case. Of course, you can write it like this. One more example. So let's look at a new example for the f. And let's do the differentiation term by term as usual. For minus 1, it becomes minus 0. Whenever you differentiate a constant, it's going to be 0. And the middle term, we keep the 4 there, and the cosine x becomes minus sine x, as I said in the first page. And for the first term of the derivative of square root of x, please recall square root of x is the same as x to the power half, right? So you can use the power rule, which means you pull the power 1 over 2 out, times x to the power half minus 1. I'm using a power rule here, so it becomes half times x to the power negative half minus 4 times sine x. And that's the answer to the derivative problem.